Hello, hello, hello. Okay. Uh, is my voice audible? Most probably, I'm gonna use the new mic for now. So yeah, let's see. Okay. So the thing is, what you have to do is like you will be given an array. Let's make a new. I have solved this before. Yeah. Let's just do a question. Yeah. Let's just make a new LL question one. Okay. Okay. So the question is, you will be given an array int arr, and for example, uh, we can make it any, but okay, no, yeah, you will be given an array, like it can have elements like 1, 3, 5, 4, many numbers, 9, 9, all of it here. Uh, thing is, you will have to take XOR of each pair and sum them up, like 1 XOR 3, 1 XOR 3 plus 1 XOR 5, 1 XOR 5 plus 1 XOR 4, so on, right? You have to take. Now, the first approach which comes to mind is that for and LLI is equals to 0, I is less than n, I plus plus, for LLJ, j is equals to 0, j is less than n, j plus plus, and here it should start with I plus 1, and here it should end at n minus 1, right? And then answer plus is equals to uh, ARR of I XOR ARR of j, right? Simple as that. But the time complexity is n square, and uh, it doesn't work, right? N square, like we can. So the important thing in bit manipulation is to remember that every bit is independent. Let me repeat, every bit is independent. So let's expand on that idea. For example, we have 7. How can it be represented in binary? 1, 1, 1. How can it be converted into an uh, decimal number? 2 to the power 2 into 1 plus 2 to the power 1 plus into 1 plus 2 to the power 0 into 1, right? Here 3 can be like 11 can be represented as mm, 8 plus 3, right? 1, 0, 1, 1. 2e3 to the 1 plus 2e2 into 0 plus 2e1 into 1 plus 2e0 into 1. Now suppose if I take if I take each power of 2 separately and then do XOR of it, then take sum of all the XORs. Will it work? Of course it will work. Now let's see. E to the power 32 into, like, what will be XOR of these? Like, what bit they will have at 32? Actually, it should be 31, right? But yeah, after expanding that thought, we can see that all we have to find is to XOR at sum of XOR at each bit, sum of XORs at each bit, each bit, not beat, bit, right? Now, how do we find the sum of XORs at each bit? Simple thing. What do we have? 0 XOR 1 is 1. 0 XOR 0, 0 XOR 0 is 0. And 0 XOR 1 is 1. 0, 1 XOR 1 is 0. Right? What if we can find, uh, how do I frame it? What if we find number of ones in the whole element and then multiply it by 0? Like multiply it by number of zeros. We will get the answer, right? I hope so. How to how do I explain it? Like if I have five numbers, five in that five numbers, three are ones and two of them are zero, right? Now, what is the total combination? What is the total possible combinations of zeros and ones, right? Let's do it. It is quite brute, brute or like brute. It is quite brute, but let's try. Like 3 into 6, meaning 5C2, right? What is 5C2? Uh, 10 combinations, total 10 combinations, right? It will be 5, 6, 7, 8, 9, 10. I will not give Zohar at anyone. Like 1, 1, 1, 1, and then again 1, 1, right? Three pairs of three ones done. Now two pairs of 0, 0, 0, 0, 0. Done. Thing. Only one will suffice, right? Now each one will have combination with 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0. Right. How many of them are there? Most probably it should be 6. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, I have taken this extra. Right. What we can see here is that the number of combinations in which 1, 0 is present is nothing but 3 into 2. Right. So we can say that the sum of XORs at each bit will be the number of ones that are present in the whole n numbers which are set to 1 into n minus like 1 into 0, number of ones and the number of zeros. Now all we have to do that we have to find each number, like we have to take an array of int count of 31. Why 31? Because uh, phew, because what is the range of integer? The range of integer is 10 to the power 9. And we can say that 2 to the power 30 is greater than 10 to the power 9. How can I say that? Because 2 to the power 10 is greater than 3 to the power 3. So if we square on both the sides, we can see that 2 to the power 30 is greater than 2 to the power 9, 10 to the power 9. So by this logic, we can say that as our integers range would be from 0 to 10 to the power 9, we can have, if 10 to the power 9, we can have 30 integer, like 30 bits, right? They would be sufficient. Now we will calculate for ln I is equal to 0. You will understand more of it when I write the code, right? I is less than n, I plus plus, llx, cnx. We are taking each number and then we are finding uh, at each bit we are incrementing the number, right? We will first declare it to 0, like increment it, like initialize it with 0, and I is equal like j is equal to 0, j is less than 32, 31 most probably, yeah, 31, and j plus plus. Now here we will do is like if x, if we do a right shift hit by j is equals to 1, no, and then return, and yeah, it will give 1 or 0, right? We will first read this. Okay, if this happens to be 1, then count of that j incremented, right? Now, as we will find it for each number, as we would have found, we will find it for each number. We will now accumulate it. We will now sum it in uh, LL I is equals to 0, I is less than 30, 1, I plus plus. We will declare an summary ANS is equals to 0, ANS plus is equals to 1 LL shift J and shift I into C and T of I into N minus C and T of I into 1 LL. That will give us the answer. Return ANS. Phew, that was a lengthy one, right? दुल्हा छोटा सा छोटी सी आशा and was not declared. Yeah, right. We will now, like, we will have three numbers because I have rectified the answer 1, 3, and 7. And we haven't see out the answer. See out and then 1, 3, 1, 3, 7, 22. How is it 22? Answer was 1, right? 12, right? Mistakes, mistakes, what mistakes? Oh, must that be 1, 3, 1, 3, 7, 22. आसमानों को छूने की आशा, दिल है छोटा सा, तुम छोटी सी आशा. Hmm. 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 I've written the code over here. What's happening? X and C++. Oh, no, I'm doing it right. Let's save it. 271 minus 1. अच्छा, ये होईल बाकी. You get it right. Ah, yeah, so that's it. Now, thing is to realize that when we take and, like, if we were given the question of finding the sum of pairs of all the ands, then we will be doing is, then what we will be doing is, uh, we will find all the ones, and then all the ones choose two. And for or we will do NC2, like number all 31 C2, mean all NC2 minus number of zeros C2. And yeah, that's it. Lambo question.